In this tutorial, I'll show you how you can prompt the user for values and how you can store them in a one-dimensional array. So for the purpose of this course, the only data structure that you're going to use will be an array. So when you're trying to solve a problem and you're trying to store a collection of values in a single place, array would be the choice to make. Okay, so let's launch our Eclipse and make sure you have your CSE114 tutorials project ready. And we are still doing an example on the loops in the loops package. So right click on the package and say new Java class. And let's create a new class here. Let's say repeatedly store values, input values from the user, let's say. And let's just call it repeatedly store input value. That should be good enough. And then with the main method here, and say finish. Okay. So now, first of all, let's just complete a part that we are going to repeatedly prompt the user for a value until they explicitly say they do not want to continue. And when they say they do not want to continue anymore, we're going to do something about the list of numbers they have entered so far. That's kind of the roadmap. Okay. And in other tutorial videos, we talk about how you can repeatedly prompt the user to enter values. Let's just review that very quickly. So first of all, because we're going to let's say we are going to read string values this time from the user. So we're going to read a line from the user, let's say names, people's name, for example. So let's say we're going to declare a scanner objects variable here, scanner input assigned to new scanner, and then system.in. Okay. And then let's before we talk about repetitions, let's program the single step first, the single action, because we're going to repeatedly prompt the user for a string values. So let's finish that prompt first. So we can say system.out.println. You can say enter a person's name, and we're going to read it and store that in a variable. So we can say string name is assigned to input dot next line. Okay, so we're going to read the name from the user. Can be Alan, can be Mark, can be Tom, can be any person's name. And then we're going to let's say system.out.println. We're going to do something about whatever we read from the user. So let's say you just, of course, this action here can be anything you like. So let me see, say read a string value from the user, a string value which denotes a person's name from the user, and then do something about the string name we just stored. Okay, because we just stored the string name into a variable called name. So now we can say you just enter the name. Okay, let's say we can quote that into double quotes and the name plus. And by the way, this is called the escape sequence. So we do not want to get confused with the ending and starting quotes of the string literal. So that's why we have to put an escape sequence here for the quotes. And here the ending quote over here. Okay, you just enter the name. For example, Alan, Mark, or Tom. Okay, so that's a single step. If you launch that, you can see that enter a person's name. If I say Alan here, they would say you just enter the name Alan, and we are done. Actually, because the program actually just terminates. You only execute this prompt step for only once, but we would like to repeatedly perform this step until the user says we do not want to continue. The way we do that is by enclosing this single step here as the loop body of some while loop. So we actually talk about this in the previous tutorial sessions. You should really refer to them if you have any doubts. So we're going to use a Boolean variable here to say user wants to enter another name, for example. Let's say Initially, it's simply true, and then we'll use that Boolean variable as the state condition of the while loop. Initially, you can see that the initial value that we assign to this variable here is simply true. That means we're going to enter the while loop for at least once. Okay. And now, so that's the while loop, and we're going to enclose this single step here that we programmed before as the body of the while loop. And of course, now what we're gonna do is to make sure at some points this Boolean variable will be set to false, so that we're going to exit from this while loop at some points. You certainly do not want to, well, we certainly want to repeat this single step for as many times as the user might wish. But eventually, you have to exit from the loop. You don't want to run, just keep letting the user to enter the name forever, right? So that's something we're going to do. Okay, so now at the end of each iteration step, we're going to ask the user, would you like to enter another new name? So you would say system.out.println. So let's say, ask the user if they wish to enter another new name. If so, we can still set this value here to be still true. Otherwise, we can set it to false. Okay, so now, would you like to enter another new name? And let's say either yes or no. So now we can have string answer from the user, which is assigned to input, which is of scanner type, dot next line. Okay, make sure it's next line here. And then now we're going to update the value of this Boolean variable. So it is going to be reassigned to the truth of whether or not the answer is equal to y. If it is equal to y, then it will be true. If it is equal to anything other than y, then it is false. So it would say answer dot equals y. Let's try again to see if that works. Okay, enter a person's name. If I say Alan here, you just enter the name Alan. Would you like to enter another name? By the way, you can see now Alan, between Alan here, we actually enclose Alan's name with double quotes. So that's exactly what this escape sequence is doing over here. So that's also useful thing for you to observe. Okay, let's go back to the console here and continue. Okay, in the console here, would you like to enter another new name? Let's say Y. We want to enter a person's name, so now we're repeating the step one more time for the second time. Let's say Mark. You just entered the name Mark. Would you like to enter another new name? Let's say yes. The third name, let's say Tom. Okay, and then we'd say no. And then we exit from the program. You can see now the button here is actually now terminate button there is disabled, which means we have terminated the program already. Okay, so now we would like to say, well, basically at this point here, you can see outside the while loop, exit from the while loop. We know that it is not the case that user wants to continue another name is true. It is not the case, so it must be false. So you can say either it is equal to false, or alternatively, you can say it is not the case that user wants to enter another name is true, right? Either way, okay. You should really convince yourself that writing this is equivalent to writing this. So that's exactly what the negation logical operator really means. Okay. So now let's say once we exit from the while loop, after exiting from the while loop, we would like to do something about the list of names that we have read from the user. So for example, we want to print it as a list. So for example, here it can be Alan, Mark, and Tom. That's one possibility here. Or maybe we want to greet to everyone in the list. So for example, we may want to print out things like hello Alan, hello Mark, and hello Tom. So it's a string value. It's a string. Basically, so far we have only read string values from the user. But if we read, let's say, integer values from the user, we can do other things. Maybe we can check to see if all the numbers that have been entered by the user are positive, or what's the average of the numbers, and what's the maximum or what's the second maximum of the numbers, depending on what values you're reading from the user. But for this tutorial, I'm only illustrating to you when you're reading string names from the user, just for illustration. Okay, so now it seems like for the program right now, we cannot really print out the list after the user finish entering, because every time when we actually store the name, we store that in a single variable in line number 14 over here into the name. And every time, let's say, the first time we assign name to be Alan, and the second time when we go back to execute this step again, we'd say enter a person's name, and then we enter Mark, for example. And then Mark is actually going to overwrite the previously stored contents of the name variable, which was Alan. So now Alan was basically gone from the variable already. So now we have for the code as is, we actually have no way to actually keep track of the list of names we have read so far from the user. To do this, we actually need more than one variable actually. So in some way, we had to store a collection of values from the user. In this case, we need to use an array. Okay. So now let's make an assumption. Okay, I'm now going to extend the program so that we actually know how we can store a collection of values from the user. Okay. Assumption. The user enters no more than let's say 10 names. Of course, this assumption here is really depends on what you really need to do for your application. But for this illustration here, I'll just say it's 10. Okay. The users enter no more than 10. They can enter either one name, two names, three names, up to 10 names. Okay. So that means if we want to store, in the worst case, the user wants to enter 10 names, in which case we need an array of size 10. So we should really account for the worst case. So let's create an array where each element is a string, is of string type. So it's a string and a pair of curly square brackets for a string array. Let's say call that names. It's assigned to new for creating a new array objects, and then string here 10. Okay, that's what you can do. And for better practice, you should really try to avoid magic numbers in your program code. Whenever you want to have a specific number here, you should really try to declare that as a constant in your Java class. So what we can do is to say final integer, let's say maximum size, like a maximum size of list that the user can actually enter for their numbers or names. Let's say it's equal to 10. So now we can refer to this maximum size over here rather than just saying 10. The advantage of this is, let's say later on, maybe it's actually very often you may want to refer to this maximum size in multiple places in your code, and you certainly, whenever you want to change this number here, let's say if you change your assumption, now the user enters no more than 20 names each time, then the only place you have to change your code will be just the value of the constant. And everywhere where you're trying to refer to this maximum size is going to be changed accordingly. You don't actually have to physically go there and change that from 10 to 20 for every place. You don't have to. This is the only place you have to change. Okay. So once we create this new array here, and we somehow have to know each time, let's say, if the first name that was entered by the user is Alan, and in that case, Alan has to be stored at index 0 of this names array over here. And let's say the user wants to enter another new name. So let's say this time they enter Mark as the second name. In that case, Mark should be stored not at index 0 because index 0 has been occupied by Alan, the first input name. So Mark should be stored at index 1. And then we have to ask the user if they want to enter another new name. Let's say the user says yes. In that case, we're actually going back to the beginning of the while loop and then prompt them for a third name. Let's say the user enters Tom in this case. In that case, Tom should not be stored at index 2 because index 2 has been occupied by Mark, which was the second input name. So now Tom as a third name should be stored at index 2 instead, right? So now, what I'm really trying to say is somehow we need a way to keep track of where we should store the new name into the array. Okay, so we actually need a counter. Yeah. So now integer counter is equal to 0 initially. So now we use a counter variable to, there are two purposes. First, keep track of how many names, how many values in more general sense. It can be names, it can be integer values, can be Boolean values, can be anything. How many values have been read from the user, and also to we can use the counter variable to indicate where the next newly read, the next user enter value should be stored. Okay, let me show you some diagram to really illustrate to you what I really mean. Let's say we have our, so now we have our string array names, and also we have a counter value whose initial value was set to 0. Let's see how this should work. Let me show you some diagram here. So now, this is the names array. Remember, we said the maximum size is actually 10. So we got index 0 up to 9 over here. Initially, the array, you can think of that is simply just empty. So every of the 10 slots simply does not store anything. Okay, that's why I just leave them blank for now. And remember, the initial value for the counter was set to 0 over here. You can see. So you can think of that conceptually. Counter whose value being equal to 0 really means that it is somehow pointing to the first slot in the array at index 0. Okay, so now counter value says two things. First of all, we have read 0 0 names from the user, because in this case we're trying to read string names from the user. So far, point number 1, counter's value being 0 means we have read 0 names from the user. And also, the next time we are reading a new name, we should store that new name at this particular position at index 0. So these are the two things. Okay. So now let's say we prompt the user for, like over here, we prompt the user for a person's name. In that case, let's say the user actually enters Alan. Okay. And so we actually set the name to be Alan. So the user actually types Alan from the keyboard. So now the name has been set to Alan. And remember, the second purpose of the counter is it indicates where the next name should be stored in the array. And it points to 0, and we just read Alan. So that means we have to store Alan into this particular position. Okay? And after this, we actually have to update the counter value, because the next time, let's say we read another name from the user, that name should be stored at index 1 over here, at index 1 rather than index 0, because index 0 has been occupied by Alan already. So what we should do next is to increment the value of the counter. So it is as if now we are shifting the counter from the left to the right by 1 position by incrementing its value. Okay, that's really how you should think conceptually. And now, let's say we are now executing the body of the while loop for the second time because the user wants to enter a second name. In that case, let's say the user enters Mark. In that case, we are going to reassign the name variable to Mark instead. So now, again, the counter value being 1 suggests two things. First, so far we have read only one name. We have stored and read only one name, which is Alan. Okay, and then the next name that we read from the user which is mark, has to be stored at position 1 in the array, which is the empty slot over here. So we're going to do it. So we store mark over here. And after that, we also have to increment the value of counter so that the next name to be read, if the user wants to enter another new name, so the next name that we read from the user has to be stored in this position. So again, we shift from counter being equal to 1 to counter being equal to 2. Okay, so you can see this process just goes on and on and on until the counter value is actually equal to 9. And then, so when the counter value is equal to 9, that means we have to store the new name at position 9. After which, we're going to increment the counter's value from 9 to 10. In that case, we have read 10 names. We have read and stored 10 names already. And 10 is already the maximum capacity of this array. So that means we cannot read any more names from the user. If the user still tries to enter a new name, that should be considered as an error because there's simply not enough space in the array. Okay, let me just do the animation again for you. Initially, counter value is equal to 0. So that means when we read the first name Alan, we're going to store Alan in position 0 that corresponds to the counter value. And for now, and then we're going to increment the value of counter by 1. So that means now we have stored and read one name in the array, which is Alan. And then we read another new name, Mark, and Mark will be stored in wherever counter value is pointing to, which is here. And then we are going to increment the value of the counter. So now there are two names that we have read and stored into the array. And the next name, the third name, is going to be stored at this particular position that is pointing to by the counter. And this process goes on and on and on until the last time we can store will be when the counter values is equal to 9. In which case, we are going to store that whatever name it is that we read from the user into position 9. And then we're going to increment the value of counter from 9 into 10. In that case, we have read 10 names, which corresponds to the maximum capacity of the array, and we cannot store new name anymore. Okay, I hope that's clear, and that's really how you should think of how this counter and array capacity works together. Okay, so let's see how we can program this in Java. So after we have read this name here from the user, first of all, we have to use the current value of the counter. So we're going to say names at position counter. That's exactly what I show you in the diagram. It's assigned to name. So we're going to put name into whatever counter value it is, position in the names array. For example, Alan, the first name, will be put into position 0. And after that, we have to increment the counter value. You can say counter plus plus, or you can say counter is assigned to counter plus 1. And now, let me just check. Counter plus plus. Okay, so now, if the first name is Alan, then we'll store Alan into position 0, and then we increment the counter value from 0 to 1. And when we go back, and the user wants to continue enter another new name, and then when we come back again, so now counter value has been incremented to 1. So now the second name, let's say, is Mark. So we'll store Mark in position 1, and etc. So these lines are really the most critical lines for you to remember. Okay. So now let me put some comments for you. So you would say store the user input name in the position. Okay, let's say at index indicated by the counter's value. Okay. You can say store in names array by the counter's value. And then we'd say update the counter's value for the next user input name to be stored. Okay, So basically, these two lines are really critical for you to understand. We are trying to use an array to store the list of numbers, and we're trying to use a counter to keep track of both how many names have been entered, and also what will be the next slot to store the new name. Okay, there are two purposes for this counter here. Very important. Okay, finally, let me actually, there are still a few things I would like to do in this tutorial. First of all, let's run a debugger to make sure you really understand. So apart from the diagram I just showed you, let's see how the debugger can illustrate the same idea. Let's now put a breakpoint over here, and we'll say run debug as Java application. Okay, so now we'll stop here. We stop here and go to the variables panel here. So now we are going to step over. You can see now we got maximum size being equal to 10. So the valid indices for the array will be 0 up to 9. Okay, in this case, we're going to initialize. We're going to create the array of size maximum size, which is 10. If you do that, okay, so now we got a names array over here, and then we're going to initialize the counter value as 0 over here, and then we initialize the Boolean variable over here to be true. So the state condition here is simply true. So we're going to enter the loop for the very first time. And then we're going to say enter a person's name, let's say Alan. If you say that and step over again, so now name has to be set to be Alan. Okay, so now if you look at, so now right before we do this assignment here, you can see counter value currently is 0. You can also see that from the variable panel here. Counter value is 0. Or you can just move your mouse over this variable over here. So both ways work. So counter value is equal to 0, which means we're going to store Alan into position 0 in this names array. Okay, for this names array, let me just draw your attention to here. You can see currently it's a string array, and we have not stored anything into there. So you can see null, null, null for every slot. So null value for now, you can just understand that it does not store anything meaningful. Okay, it's just a special word in Java code now. We'll talk about this later in the lectures, but for now, you can just understand that null simply means nothing meaningful. Okay, so now once we say step over, we're going to store Alan at position 0 in the array. So now I would like you to pay attention to what's going to change for the names over here. Okay, so we will predict after stepping over this line here, Alan is going to be stored at position 0 over here. Okay, so if you step over, indeed, Alan has replaced position number 0 from null to Alan, right? And now counter value used to be 0. So now we're going to say the next name to be read from the user has to be stored at position 1 instead, rather than position 0, because position 0 has been occupied by Alan and should not be wiped out. So we're going to execute this line. So now counter value has become 1. Okay, it has been incremented from 0 to 1. And now we will just simply say you just enter Alan. Okay, would you like to continue? Let's say we would like to continue. Yes. Let's say y here. And then, of course, indeed, y is equals y. So it's going to be true. So now user wants to continue another name. User wants to enter another name is going to be true. So that means we're going to enter the loop for the second time and to read a second name. So now read a person's name, let's say Mark in this case. So now when we read Mark, you can see the name has been reassigned to Alan. Has been reassigned from Alan to Mark. So now you can see now the counter value has been incremented from 0 to 1 already. So now this means we're going to store Mark into position 1 in the names array. Okay, and now if you look at the names array, position 0 has been occupied by Alan. So storing Mark in position 1 should be the right choice. So now I would like you to pay attention to what's going to happen in position 1 here. We should predict not only that Mark should be stored at position 1, but also Alan should still be there. Okay, Alan shouldn't be wiped out. So now if you say step over, you can see Mark now has been stored at position 1 and Alan remains to be at position 0. And now the counter value, we have to increment that from 1 to 2, which means later on when we read another third name, if the user wants to enter another third name, then that means we're going to store that third name over here. Okay, so now if we keep going, and then let's see. In this case, you can see now the counter value has been incremented to 2. Okay, so now and we're going to print it out and say you just enter the name Mark. Yes. And now, would you like to continue? Let's say if you say no. And now we are going to actually so now we're actually going to exit from the loop. You can see once we do that. So now we're here. So you can see so far we have exit from the loop. You can see the array over there. Okay, I'm going to show you the array in a moment, but you can see now the names is here. Yeah, so you can see the array is Alan and Mark, so only 2 names over there, and the counter value is 2, which means so far we have read and stored 2 names into the array. So we haven't written any code yet to actually process this array, but if we want to, let's say if you want to print out the names in the array one by one, in that case you have to run a for loop, and the counter value should be from 0 up to 2 only, rather than 10, because you can see the names array, you actually got Alan and Mark only, but for for the rest of the array, they have not been filled in yet. Okay, let me show you. Let me show it to you. Okay, so now let's go back to Java here, and now let's say we want to print out a list. Okay, so now you would say for integer. So now we are actually outside the while loop. We say for integer I is assigned to 0, I less than. Let's say, let me illustrate to you the wrong way of doing this. If you simply say names dot length, which is 10. And I plus plus. If I simply say system dot, let's say we would like to print out the name in this kind of form. Okay, so we're gonna have system in the same line. So we're gonna say system dot print, system dot out dot print, and angle brackets here, and we're going to end it with the right angle brackets. And we're going to put a new line over there, okay? But in the middle, it's going to be on the same line. Okay, we're going to say system.out.print and names I over there. And so now, for example, the first name, the second name is going to be followed by a comma. So only the last name is not going to be followed by a comma. So we're going to say if I is not equal to the last index that we're going to look at for the name. So in that case, maybe you can say not equal to names dot length minus 1. So names dot length minus 1 would be the last index you have to look into. Okay, if that's not the case, then we can put a comma afterwards. So now we can see system.out.print. Okay, you can put a comma here, and maybe with a space. Okay, let's give it a try and see how that works. Let's say enter a person's name. Let's say Alan. I would like to continue. Mark. I would like to continue. Let's say Tom. I don't want to continue. You can see now the output is actually something looks like this. We do have Alan, we do have Mark, we do have Tom. However, we still got the rest of the array being printed out with null elements, with null values there. So this is apparently wrong because the user has only entered Alan, Mark, and Tom into the array. We only store 3 names into the array. So when we print them out, we should not print the rest of the array which has not been occupied yet. So the source of this problem here is we should have used the value of the counter that has been consistently updated inside the loop. We should really use that to actually control the exit of the for loop to say to which point of the array should we actually print out the contents, but beyond which point we're actually not going to care too much because those slots of the array have not been occupied yet. Okay, so what we should do is to say counter over here. Okay, and of course put a semicolon here. Okay, so what we should do is just say counter here. Let's try again. Alan, Mark. Oh, sorry. Let me do it again. I didn't do that properly. Alan, yes, I want to continue. Mark, I want to continue. And Tom, and I do not want to continue. So now you have Alan, Mark, and Tom. Okay, but somehow it does not you shouldn't put a comma after Tom. It could be something wrong here. If I is not equal to names, okay, so I should have changed this as well. Okay, this is to say, well, we are only going to print out the comma after every name except for the last enter name. In that case, if I is not equal to counter -1. Okay, I'm going to show you in a moment. Okay, counter -1. The reason is because we're actually going to run the loop counter from 0, 1, 2, 3 up to and including counter -1. Okay, in this case, let's say we have entered Alan, Mark, and Tom, and then the counter value would be 3 because we have read and stored 3 names. So counter value will be 3. So that means i's value here would be 0, 1, and 2. So the last value we're going to use for the loop counter would be 2. Okay, so 3 minus 1 would be 2. Okay, that's how I work it out. Let's do it again. So Alan, yes. Mark, yes. And Tom, and that's it. Okay, Alan, Mark, and Tom. Okay, so it's really, really critical for you to understand why we have to use the counter value here rather than the names.length. But for completeness, I would like to illustrate to you in the debugger why it should work like that way. Okay, so now why don't we try the following? Let's try again. Debugger. Okay, I would say run debug as Java application. Okay, in this case, I'm actually going to step over and then initialize the names, which we did already. So I'm just going to go straight to my points. So just watch I would like you to watch how the counter value actually changes, okay? It's going to change from 0 to 1 and then to 2. Let's say we're going to read 3 names from the user, Alan, Mark, and Tom. Okay, enter a person's name. So we have, let me just show you the expressions actually here so we can be more focused. Let me just delete the previous one. And okay, so now I'm going to watch the value for counter and we're going to watch the value for counter and also the value for so we have counter and also we have the names array. Okay, so these are the 2 things we're going to watch for. Okay, so now let's say so now you can see the counter value initially was 0, and now let's say Alan is the first name. Okay, let's say step over. So now after we have, let's say, let me expand this names array. You can see initially all the slots are unoccupied, so that's why they're simply just null value here. So now you're going to actually go for step over, and you can see that we're going to store Alan into position 0 in the array. If you do that, you can see Alan has been changed to there. And then we actually increment the value of counter by 1. So you can see the change over here, okay? Has been incremented from 0 to 1. Okay, let's do another one. Would you like to continue? Yes, I would like to continue. So now we will go back to the beginning of the while loop, and because it has been set to true. So we'll do the second name. So now the name, let's say Mark. You can see up to this point now, because we have only stored Alan in the names array, so that's why counter value is 1. But now we're going to store mark into position 1, which is the second position in the array. And then we'd say do it. And now you can see mark has been set in position 1 of the array. And also the counter value, we're going to increment that from 1 to 2, which means the next name, which we're going to read from the user, is going to be stored at position 2, which is the third position in the array. And now let's step over, and would you like to continue? Enter another new name. Let's say we want to. So you would say yes. Okay, let me just do another one for you. So now user wants to continue, also has been set to true. So we're going to enter the loop for the third time. If you do that, enter a person's name. So let's say it's Tom for the final time. And you will see that name has been set to Tom. So now, so far, you can see the counter value is actually equal to 2 because we have only stored Alan and Mark into the array. And we're going to store Tom into the position 2, which is the third position in the array. Okay, if you step over, you'll see that Tom has been set to position 2 in the array. So we got Alan, Mark, and Tom. And now we're going to increment the value of the counter, and it now becomes 3. And then we're going to, would you like to continue? Let's say no, we are done. Okay, so now if you say no here, and you're going to say, so now user wants to continue, has been set to false. So now we're actually going to exit from the while loop. Up to this point, you can see that the counter value has now been set to 3. It was initially 0, but after we store Alan into position 0, we incremented the value of counter from 0 to 1. And then after we store Mark into position 1 of the array, we incremented the value of counter from 1 to 2. And then we actually store Tom into position 2 of the array, and then we incremented the value of counter from 2 to 3. So you can see now up to this point here, we have exit from the loop, and now the counter value being equal to 3 means that we have stored and read 3 names into the array, Alan, Mark, and Tom. So we can use this value here to control to which point we should really read the input values that we have stored so far. And beyond this point here at position 2, well, basically we're actually going to run a for loop where the counter value is going to be strictly smaller than counter. Okay, because you can see the counter value is equal to 3, and at position 3, that is the first point where we have the unoccupied slots until the end of the array, which we don't care to actually print them out, right? So that's why you have the strictly smaller than equal sign. So it's very important for you to understand why we're using less than rather than less than or equal to. Let me say it again. So the counter value here is 3. That means so far we have stored 3 names into the array. And the position that was corresponded by this counter value here is 3 over here. That is the first slots, the first unoccupied slots in the array, from which points we don't actually care to actually process them. We only care all the points, all the slots that actually occur before this counter value, which will be indexed 2, 1, and 0. Okay, so you should really work yourself out to see why we're using this counter value here rather than names.length. Okay, very, very important. Okay, so now let me do another experiment for you, which is also quite important. So currently, the program seems to work. We can actually store up to 10 names from the user. But let's say, what if the user actually, after they enter 10 names, and then they simply try to enter another new name, and they still answer Y to say, I would like to enter another new name. Currently, your program has no way to stop them to do that. Let me illustrate my point first and see what happens. Let me try to launch the program. Let me so I'm going to enter 10 names, but for convenience, I'm just going to say N1. Okay. You just enter N1, you can see here, okay? So you can just follow the number here. I'm going to store N1 up to N10, which means it's going to fully occupy the internal array of names for 10 slots, okay? I would like to continue, and then I'll say N2. I would like to continue, N3. I would like to continue, and then N4. I would like to continue, and then N5. I would like to continue, and then N6. Yes, and 7, and also Y, and 8. Y, and then N9. Y, and 10. So far we are okay. So we have entered 10 names, and 10 is actually is smaller than or equal to the maximum size, which is 10. But now the program actually allows us to enter another name. Okay, let's see what's gonna happen. Okay, if I say N11, okay, I would like, before I do that, I would like you to, okay, actually, let me just do that now. If I do that, somehow it will just print out N1 up to, oh, actually I should have said Y here. Sorry, that's my mistake. Can I just do it again? So I was actually wondering. So let me do it again. So a person's name, let's say N1. I would like to continue. N2, yes. N3, yes. N4, yes. N5, yes. N6, yes. N7, yes. N8, yes. N9, yes. N10, yes. Okay, so now if I say N11, so now I actually got something that's something called an exception in Java, which means something called array index out of bounds exception. Okay, so since remember the counter value we set. So after N10 has been stored into the array, so the counter value would have been incremented from 0 all the way to 10. So now remember the size of the names array is simply 10, which means 10 is not a valid index for an array of size 10, because an array of size 10 has only valid indices from 0 to 9. But now, if you try to use the the last counter value after N10, which will be 10, to actually store into index 10 into the names array, it's not going to work. So which means we are trying to store the 11th name into an array of size only 10. So that's something called index out of bound exception, which means we are trying to store the elements into an index that simply does not exist for the array given the length. Okay, and where does this happen? You can actually click on this over here. So in the main method, so this is where it happened. So this is exactly the point where we're trying to use the counter value, which is 10, after we have stored 10 names in the array. And then we are trying to store name, which is N11, into position 10 in the names array. Again, names array has only size 10, so the maximum index you can refer to will be 9, not 10. So that's a problem. Okay, so now, how can we fix that? So somehow we have to make sure that whenever you're trying to store, so we were simply making the assumption that the user enters no more than 10 names, but what if the user is not aware of such an assumption? So to make your program more robust, so that's the word, which means we have to account for all the possible values or all the possible behavior pattern by the user. Okay, we can say to make the code more robust, i.e. we want to handle also the case where the user enters more than 10 numbers. Okay, to make the code more robust, we we have to exit from the loop if so far we have stored maximum size, which is 10. Okay, depending on what the value has been set up, the store maximum size names in the names array. In this case, that will be 10. Okay, so now we have to modify the state condition a little bit to say, well, before we say that as long as the user wants to continue, we can let them to continue to enter the name. That's wrong actually, because after the user enters 10 names, if they still want to continue to enter the 11th name, that should not be allowed. So now we should really make this state condition more restrictive by using a conjunction to say, in order to stay in the loop, not only that this has to be true, but something else has to be true as well. So we'll say that not only that the user wants to continue, but also the current counter value, which will indicate how many names we have entered so far, must be less than or equal to the maximum capacity, maximum size of the array. So whenever the counter value reaches this maximum size value, in this case it's 10. So which means whenever we have incremented the counter value from 0 all the way to 10, that means we have stored 10 names in the array. That means the array is full. So in that case, the user certainly cannot continue anymore. Okay? In that case, we're actually going to say, well, if the counter value is strictly larger than maximum size, then it's going to make this part false. And it's going to force the while loop to exit, right? Okay, that's really important to remember. So now, we can simply say, exit. So now we can update this part of the explanation a little bit. Exit from the while loop means two things. Yeah, so it's going to be the negation of this Boolean condition here. So here, remember what we said before in the class. So let me just copy that. So exit from the while loop means the following. It's going to be the negation of the state condition. Okay? And if you apply what we learned from the class, it's going to be the negation of the left-hand side or the negation of the right-hand side over here. And if we simplify that a little bit, it's either not the case. It's either not the case that the user wants to enter another new name, which means they enter n or no or anything other than y, or the negation of this would be counter larger than maximum size. Okay, that's what we have to be careful about. Okay, let me see this. Something we have to think very carefully about. Should this be less than or equal to, or should this be less than? Okay, so I claim that we should actually use less than over here because if you think about the argument over here, so if we put a less than here, and if you put a less than here, then this part here will become greater than or equal to, which means we're going to exit from the loop if you have entered either the maximum size of elements and a maximum size of string names, or yeah, basically let me just illustrate to you, okay, and then we can talk about the logic in moments. Okay, so now let's do a debugger. Okay, if you say, and now let me just change this part here just to 5. Okay, just for easier illustration, you can change it to any number you like. Let's say just 5. So now maximum 5 names. Okay, maximum. If I say run debug as Java application, okay, maximum size is now 5, not 10. Okay, you can change that back later if you like. Okay, so now names array has only 0, 1, 2, 3, 4. Okay, 5 elements there, and then counter value equal to 0, and then initially the Boolean variable is true. So now counter is currently equal to 0, and which means we have to store 0 names in the array, and the maximum we can store will be 5. Okay, 0 is strictly less than 5. Okay, so which means we have more names to be stored. Okay, I think the way to think about this Boolean condition here is if the counter value, which indicates how many names we have stored, is strictly less than the maximum number of elements or maximum number of names we can store in the array. If it is strictly less than that, So that means there's got to be one or more names we can store in the array. That's how you should think of it. Okay. So now this part here is true, and also 0 less than 5 is also true. So true and true. So we got true. Okay. So now we're gonna do okay. Let's say n1. Okay. So we store n1 into position 0, and counter value has been incremented to 1. Okay. So far so good. Let's say we would like to continue. And now, let's go back here. And now we can see that this remains to be true, and counter value is now 1. 1 is strictly less than 5, which means we got 4 more names to be entered, right? So 1 is strictly less than 5. So that means we got 4 more names to enter. So later on, you should really convince yourself why we have to use less than rather than less than or equal to. Okay, a very important question for you to think about. And then we go for enter person's name. Let's say N2, second name. Okay, you can see that now after these 2 lines over here, we actually store N2 and also counter value has been incremented to 2, which means we got 2 names stored so far. Okay, we're getting there. So now I would like to enter another new name. And then, so now you can see this part here is true. And then counter value is 2 is strictly less than 5. So we got 3 more names to be entered. Okay, so now we can read a name. Let's say N3. Okay, and then, so this one, after this, you can see counter value. So now the third name has been stored, and also counter value has been incremented to 3, which means we have stored 3 names so far. Okay, and then would you like to enter another new name? Yes. So now it's going to be true, and then again true, and then here we got 3 strictly less than 5. Okay, let me just go on. You can also run the debugger yourself. Okay, let's see M4, fourth name. And after that, we would expect the counter to be incremented to 4. And I would like to continue. So now you can see that true, and then 4 strictly less than 5. If you do that, let's say we want to enter M5. And then after that, we're going to store so 5 names so far, N1, N2, N3, N4, and N5. And then we're going to say, would you like to enter another new name? So now, let's say if the user actually is not really aware of the fact that we only can store maximum 5 names because we set the maximum size to be 5. And indeed, they have entered 5 names already. But what if they said, I would like to enter another new name? What happened is, before, let me say, so this part is going to be set to true, okay? before we introduce this part to the state condition, let's say if we didn't have that one, then it's going to make user wants to enter another new name simply true. That's going to make the state condition true. So we're going to enter another new name and then store the name at counter value at position 5. And position 5 is simply not it's not a valid index of the array of size 5, because you can see the maximum index is 4. There's no 5 here. So we simply should not allow the user, we should not allow the loop to be executed one more time. That's something we should forbid. That's why we actually introduced this part of the state condition. So now counter value has been incremented to 5, which means we have stored 5 names already. And it is not strictly less than the maximum size. So it's going to make this expression here false. And false and true is going to be false. That means we are forced to actually exit from the while loop. That's how we protect the the indexing of the array from getting the runtime exception, like the index out of bound exception we just observed. Okay, so that's very important. So I hope that's detailed enough for you to understand why we had to introduce this condition here to make sure if you try to enter more than the number of elements in the array, that you have to be careful. You have to make sure your code can actually force the loop to actually exit when you simply have no more elements to be stored. You simply have no space for the new elements to be stored. Okay, let's see this. And let me just show you one more thing before I end the tutorial. You can see that the counter value is actually very important, and you can actually use the counter value to do some very useful reporting. To say, for example, how many names you have read so far and how many more names you can expect to actually store. So what we're going to see here, system.out.println. So every time after we update the current value of the counter, you can say you have entered, let's say, counter value names. And you can also say that system.out.println, you have how many more. Okay, so it's going to be the maximum size, because we know that it's going to be strictly smaller than maximum size when we first enter the loop. And after incrementing that, incrementing the counter value, the value is going to be less than or equal to maximum size. It's a pure math, actually, to say it's a mathematical analysis. Okay, let me just write it down for you, just for completeness. We know from the state condition counter less than maximum size. So incrementing counter's value from line 30, okay? From line 30 means that counter is going to be less than or equal to maximum size, okay? Which means we may or may not have reached the maximum size. If we have, that means no more number to be entered, okay? Maximum size minus counter. Also guaranteed to be either 0 or 1 or 2 or more, right? You have more names to enter, okay? Let's see how this works. Do that. Enter a person's name, let's say Alan. You have entered one name, you have 4 more names to enter, right? Yes. Let's say Mark. 2 names, 3 more names to enter. Let's say I would like to continue. Let's say Tom. Okay, and then 2 more. Let's say yes, Jonathan. Yes, and let's say Simon. Okay, no more. Even if I say yes right now, I will still be actually forced to actually exit from the loop, right? And then they will still print out just Alan, Mark, Tom, Jonathan, and Simon. If you really like, what you could have done, I think we also did that in the previous lab exercise. You can say, well, let's say if the user has already entered the maximum number of names in the array, but they still want to continue. In that case, so we can do several things if you like. You know, the simplest thing you can do is so when we actually exit from the loop, we know that counter must be larger than the maximum size. If that's the case, we can print out some message to tell the user, you simply have occupied all the slots. So you can say if the user wants to enter another name, so let's say if the last answer we got from the user was simply NY, okay? So now that means this will be set to true. And at which point they say yes, but they have already reached the maximum number of names they have entered. In that case, you would say counter larger than or equal to maximum size. If that's the case, you can just warn the user to say, well, although you said you wanted to enter another new name, but you simply couldn't do that because you have already entered 10 names or 5 names already. So you can say that you couldn't enter another new name because the array is full. Okay, let's do it again. Let me just show you again. So now if you try that here, Alan, okay, 4 more names. Yes, Mark, 3 more names, and Tom, and then let's say Jonathan, and let's say Jim. Okay, no more name. So now, at this point now, you can see we have entered 5 names, so the counter value is larger than or equal to the maximum size, which is also 5. And now let's say if we say y over here, which means it is going to set this Boolean variable here to be true. Okay, but the problem is if you go to the state condition there, because the counter value is no longer strictly less than maximum size, which means we must exit from the loop. But now after that, user wants to enter another new name, yes, but the counter value is already suggesting that we have no more names to be entered. Okay, so now in the console here, we say y. So you're gonna say you couldn't enter another new name because the array is full. Okay, that's a more meaningful message you can actually print out to the console to inform the user. Okay, it's quite a long tutorial for this exercise here, but I think it's absolutely critical for you to understand the whole story about how you can actually use an array and the counter value to actually keep track of the number of elements that's being entered from the user and store them one by one from left to right into the array. And also, you should really understand why using just the Boolean variable alone is not sufficient, because if the user already entered the maximum number of elements in the array, if the user's value have fully occupied the array, then and the user is not aware of this and they try to enter another number, in that case, as I illustrated, you're going to get the array index out of bound exception. So that's why we also introduce another new parts of the state condition and using a conjunction to say, well, you can only stay in the loop if the user wants you to do so, and more importantly, they so far have not entered the numbers so far they have not entered the numbers or names that are actually going to fully occupy the array. So which means we're going to make sure they can only continue to enter a new name if there's space for them to do so. Okay? And then after that, we can simply use the counter value and the Boolean variable to say, well, if the counter value, the number of names, have already exceeded the maximum capacity of the array, but the user still wants to continue, then we can give them some warning message. And then after that, we can simply print out the names that have been read so far. Okay, so please study this tutorial very carefully, because this kind of pattern will be very useful later on as well. Okay, stay watching.